3.6 goes into some removable discontinuities, which are holes, and it goes through slant and non-linear asymptotes. So we'll talk about objectives A and B today, and then we'll do our applications tomorrow. So a removable discontinuity occurs when a factor from the numerator and denominator cancel. So, I know looking at this that x can't equal 4. I want to go ahead and factor because I need to see if I can simplify. So I'm going to factor the numerator. So multiplies to be -4 and adds to be -3. That's going to be x plus 1, x minus 4. Well, then I see that those cancel, leaving me just with x plus 1. So, since the x minus 4 canceled, on the graph, it shows up as just a hole. If it did not cancel, then that's where you get an asymptote. That's where you'd have a vertical asymptote. But when it cancels, it becomes a hole. So I have just this linear equation, but I gotta remember I didn't start out just like this. So this x not equal to -4 still applies even in simplified form. So my graph is just a line, but I gotta remember that I have this hole here where x can't be 4. Alright, it's called removable because it cancels out. So we're going to graph our equation now, just the x plus 1, which is linear. So when you want to graph a linear equation, you use your slope and y-intercept. What's the y-intercept? 1. What's the slope? 1. So up 1, right 1. So I'm just going to graph this line, and then I'll put the hole in after I graph the line. So you can go up 1, right 1, or down 1, left 1. So make sure you do graph this all the way through. Okay, well, I know there is a hole there somewhere, and so I want to locate that. I know the hole occurs where x equals 4. So I put 4 in to see what the y coordinate would be there. So you plug it into the simplified one. whole location is at 4, 5. Sure, so you got to go where x is 4. So then you see it meets your line right here. Yes, you can look on your graph, but if it asks you to write it down, you got to write what that ordered pair is. So I have a hole there. Okay, then it's saying we could repair this equation by filling in that hole. So making a piecewise function. So we take our original, which simplified down to x plus 1, but I know that for that one, x can't equal 4. So then I fill in the ordered pair that I need to fill that hole, and that's 4, 5. So remember, f of x is y. So y equals 5 when x equals 4. So all it's asking you to do is just fill in the hole with a point you need. F of x means y, so y equals 5 when x is 4. Okay, questions about that? All right, we'll grab another one of these later. Now we're going to talk about slant asymptotes. Okay, so a slant asymptote will occur when the degree of the numerator is 1 higher than the degree of the denominator. So if we think back to our horizontal asymptote rules, if n is greater than m, so if the one on top is bigger than the one on the bottom, then there's no horizontal asymptote. That would mean there's either a slant asymptote or a non-linear asymptote. So you're not going to have both. You'll have a horizontal asymptote or a slant or nonlinear asymptote. Okay, so what we do is long division, and we're looking for the quotient part. So just the part that's on top, that will be the equation of our slant asymptote. So I'm just doing this division problem. So I'm going to divide 3x squared minus 4x plus 1 by x minus 3. So what do I multiply x by to get 3x squared? 3x, and then remember you're going to distribute, so that's 3x squared minus 9x. Long division, you subtract down. Okay, negative 4x minus negative 9x. Positive 5x. Bring down your plus 1. What do you multiply x by to get 5x? 5. So plus 5. So you're back at the top and distribute 5x minus 15. Subtract down. This gives me 16. I don't care about the remainder though, so I only want the quotient. Okay. So that tells me you have a slant asymptote. Okay. At y equals, so it says y equals q of x. It has to be an equation. 3x plus 5. So you have an asymptote that's a line, not just a horizontal or vertical line. So if you want to think about, what that might look like on a graph, so this is just the asymptotes here. I know I have a vertical asymptote because at x equals 3, as long as that didn't cancel, and it doesn't. So x equals 3, I have a vertical asymptote. And then I have a slant asymptote with this equation. So the y-intercept is 5, and I go up 3, right 1, and okay, so those are just the asymptotes. Those aren't the actual part of the graph, but that's what our asymptotes will be looking like. Okay. All right. We also can have non-linear asymptotes. So that asymptote was still a line, even though it wasn't horizontal or vertical, it was still a line. We could find asymptotes that are not linear. Right, we're going to do long division again to find the equation of that asymptote. So I'm dividing by x. So x cubed plus x squared plus 0x, so don't forget that placeholder, minus 2. Okay, I just have a single term, so I have to just go one term at a time. Since x is by itself, I just have to go one term at a time. So what do you multiply x by to get x cubed? Okay. So that cancels, bring down x squared. What do you multiply x by to get x squared? X. Okay. So x squared, subtract your 0x. Okay, what do you multiply x by to get 0x? 0. And then you bring down your -2, which is your remainder, because you can't multiply x by anything to get something without an x. Okay, so here is my non-linear asymptote. So that's y equals x squared plus x. Well, I know it's nonlinear because it has an exponent other than 1. It's x squared. So this is a parabola. So now I have the graph of a parabola as an asymptote. So again, on a graph, first of all, I have a vertical asymptote because x can't equal 0. So I have a vertical asymptote here. And then I have this asymptote x squared plus x. So what that looks like is a parabola. So I still dash in these asymptotes so we know they're not actually part of your graph. So you'd want to find the vertex and then either plug in points to find other points, or A is 1, so you could use the pattern where you go over 1, up 1, over 2, up 4, over 3, up 9. Remember, I'm finding vertex when it's in standard form. There's that little equation opposite of b over 2a. So b is 1, so -1 over 2. A is 1, so 2 times 1. That's -1/2. That's your x coordinate of the vertex. And then to find the y coordinate, you plug that back in for x. And that's 3/4. So your vertex, -1/2, 3/4. I love that asymptote. So if you're doing this on a problem where you're graphing the whole thing, we're not just trying to find the equation of the asymptote, your graph would need to be accurate. All right, you should find where that vertex is and have this graph accurately. Okay. Okay, so we've looked at the holes, we looked at the slant asymptotes, and we looked at nonlinear asymptotes. So now let's just practice graphing everything where we have a whole problem that we have to graph. Okay, x-intercepts. Those are zeros of the numerator. Well, my numerator is not difference of squares, but I can factor it like difference of squares. So we talked about this a couple days ago. So I have to just leave it as radical 6, since 6 is not a perfect square. So x plus square root of 6, x minus square root of 6. That does not cancel with your x plus 2 on the bottom. So the negative 2 is going to be an asymptote. If it cancels, the negative 2 would be a full. Okay, so my x-intercepts will be square root of 6, 0, and negative square root of 6, 0. Are these imaginary numbers? No. They're just irrational. Yeah, they're not imaginary, so you can graph them. Even though they're irrational and they're decimals, you can still graph them. Okay, the y-intercept, you still plug in 0 for x. So that should be negative 3. Vertical asymptote. So it's the zeros of the denominator, what x can't equal. So the equation of my vertical asymptote would be x equals negative 2. Horizontal asymptotes use the NM rule. So the degree on top is greater, equal, or less than the degree on bottom. It's greater. So that was that rule 3, meaning there are none. So since there's not a horizontal asymptote, there's also not a hole, we have a vertical asymptote. I know there will be a slant asymptote. Okay, so I got to do long division. I got to figure out the equation of that slant asymptote. So x plus 2 over x squared plus 0x minus 6. So what do you need to multiply x by to get x squared? X. And then distribute, so x squared plus 2x. And then subtract down. So 0x minus 2x is negative 2x. Bring down your minus 6. What do you need to multiply x by to get negative 2x? Negative 2. So really from here, you don't need to finish because you don't care about your remainder. You're only looking for the quotient. And if you want to go ahead and write it down, that's fine. But we are looking for this. So the equation is y equals x minus 2. You have to add that y equals part. Okay, for our domain, we can just go back to the equation. So we've done domain over equations like this plenty, and then we'll see it on the graph as well. So I know from here, x can't equal negative 2. So as a domain, that's negative infinity to negative 2, union negative 2 to positive infinity. That gives me that hole, that skip at negative 2. Okay, so let's graph what we have, and then if we need additional points, we'll find some additional points. Okay, my x-intercepts. So square root of 6 is approximately what? 2.4, something like that. Okay, so I have 2.4 and negative 2.4. I have a y-intercept at 0, negative 3. A vertical asymptote at x equals negative 2. Oh, this is they're not right on those. Here we go. A vertical asymptote at x equals negative 2. I have a slant asymptote at y equals x minus 2. So I have a y-intercept there for that line at negative 2, and my slope is 1. So I want to make sure and dash this as well because it's an asymptote. Okay, so we've said that you need points, at least one point in each region. And your regions are divided by the vertical asymptotes. So I'm looking at the vertical asymptote. Do I have at least 1 point left of that? Yes, do I have at least 1 point right of that? Yeah. So from here, I'm fine if you plug it in your calculator and see what the graph is doing. You're welcome to use more points, but go ahead and look in the graphic calculator. Okay, so go to y equals, you need parentheses. So it's x squared minus 6 divided by over, okay, so you have it over, x plus 2. Standard window is fine, so you can hit zoom 6. Okay, remember the calculator does not graph the asymptotes, but you can see where the vertical asymptote is and also where that slant asymptote is. So that shows me that my graph is just following these asymptotes here. Okay. Everybody able to get that? Calculator? If not, come talk to me because you're going to want to know how to do this for your test. All right, any questions? Okay, let's look at another one. Yeah, x squared minus 2x minus 8. You need to go ahead and factor because you need to know if it cancels or if it doesn't. So what multiplies to give me negative 8 and adds to give me negative 2? Yes. Okay, so does the x plus 2 cancel? Yeah, But instead of being an asymptote, it's a whole because it cancels. So I end up with just x minus 4. Okay, let's go ahead and do the domain. So you know x can equal negative 2. You can go ahead and do your domain from that. It's going to be the same domain as the previous problem, even though the previous one was an asymptote and this one's a whole. You're just looking at your x values. So it might show up differently on the graph, but the domain is still the same. Okay, so I would have one x-intercept that's at 4, 4, 0. I should be able to tell my y-intercept without having to plug 0 in for x, but you can. So here's my equation. What's the y-intercept? My equation, negative 4. That's in slope-intercept form, so that gives you your y-intercept. Okay, vertical asymptote. Well, I don't have a denominator anymore. It is none. X can equal negative 2, but that shows up as a whole, not an asymptote. There's also a horizontal asymptote. I just have that line. It has a line. Okay, the whole location. So the whole is where x is negative 2. So the y-coordinate, I plug negative 2 in for x, negative 6. So the whole is at negative 2, negative 6. And then we graph. So all this is a linear equation with a whole negative 2, negative 6. So let's graph our line. So this x-intercept at 4, 0, this y-intercept at negative 4, or 0, negative 4. And I have a whole at negative 2, negative 6. Okay. My slope is 1, so I can fill in if I need some more points to help me draw. Okay, draw a nice straight line all the way through your graph. Questions about that? Okay, that is as far as we got in third hour, so we're going to stop there today. And we'll do the last graph of this tomorrow, along with some word problems.